Hey everyone, my name is Matt DiNapoli. I'm a manager of developer advocacy with Cisco DevNet and developer relations.
I am Kareem Iskander. I'm a lead technical advocate with Cisco Learning and Certifications, and welcome to episode 74 of DevNet Snack Minute.
DevNet Snack Minute is your weekly 10-minute all things DevNet that teaches you about coding, APIs, or just some cool stuff we think you might like to know.
And the cool thing we're going to talk to you about today is with our guest, Shannon McFarland. Shannon,
yeah, we're going to talk about Calisti.
Calisti. I saw your session. It was pretty awesome. Thanks for joining us.
Thanks for joining us, Shannon.
Yeah.
Yeah.
How's it going?
Thanks for being on.
Sure.
I'm going to start this off. Earlier this week, yesterday, you had a session called Your Mess Needs a Mesh. Can you tell us a little bit about what you mean by that? And then how...
But first, he has to introduce himself.
Oh, I'm so sorry.
Yeah.
I was jumping ahead. Okay, I'll ask the question.
You're good. Shannon McFarland. I'm a distinguished engineer with emerging technologies and incubation. So we've got a booth. Matter of fact, I can see the banner of it clear over there. We're basically Cisco's internal startup engine. So we acquire companies and integrate their technologies in our group, or we invent things from scratch that aren't being invented in other parts of the company. So that's the group I'm in.
Cutting edge stuff.
All right, now to my question.
Yes.
You had a session yesterday called Your Mess Needs a Mesh, and I'm curious about if you can give everyone kind of a little bit of a rundown of what you mean by that and how some new Cisco product plays into that conversation.
Sure, yeah, I've been doing the Your Mess Needs a Mesh, and I almost, during every one of those sessions, reverse those two and say your mess needs a mesh or your mesh needs a mess.
Yeah.
And I usually do the latter. But I've been doing that talk for quite some time because it's a common theme that we see in a microservices environment where people just kind of naturally think that once I get into a distributed microservices architecture that lots and lots of my problems go away around common infrastructure component consumption. And the reality of it is if you don't have proper tooling and a proper operational model, actually microservices will make that situation worse, because what happens very often, this is very true, what I've seen in a lot of enterprises, is that microservices will still have ownership in different groups, and each one of them have their own select languages they work in, their own tool sets. They like doing logging a certain way, load balancing a certain way. And because they have just distributed the architecture implementation differently, doesn't mean that they've actually restructured their operational model around it. So that equates to a mess, right?
Yeah.
You've got everybody doing logging, everybody doing load balancing, everybody doing MTLS and so forth, their own special way. You glue all those things together, and the second anything goes wrong, you have no root cause analysis. Finger pointing is still there, and so one of the things that what we use as a tool to kind of help resolve that is we use a service mesh, an application service mesh, which is quite popular. There's many of them out there, Istio, Linkerd, several of them out there. And basically a one-worder for a service mesh is that it's an infrastructure component for service-to-service communication. Right. So one of the things that we find successful is, if this is a challenge that people have, is let the developer write the code they want to write, which is the business logic. Mm-hmm. Don't make them be load balancer experts. Don't make them be MTLS and cert rotation experts and so forth. Offload all of those things, circuit breaking, traffic redirection, all those things into the service mesh, and then go back to writing business logic code. And so that's kind of the essence of what that session's about.
Okay.
And one of the things that's come out of our team is a commercial solution for Istio service mesh, and it's called Cisco Calisti. And again, over there in the booth, you can actually go in and take a drive there and check it out. We've got a free version of that. You can sign up at calisti.app. They can you get 10 nodes with 2 clusters for free. Comes with the whole lifecycle management, the UI, the whole 9 yards. And so that's kind of what the essence of that session is about.
Can you comment on the kind of Cisco secret sauce that we're popping on top of this Istio service mesh?
Yeah, absolutely. So Istio is a very robust and extremely capable service mesh standalone, but operationally, while it has improved over the last few years, things like lifecycle management of the cluster itself, right? So if you're doing canary releases of the control plane or the data plane, whatever it is, those can still be quite painful. If you're doing multi-cluster configurations where you've got Kubernetes nodes all over the place, or clusters, and you are distributing your microservices environment across them, it's a lot of per command line type of integration to link those things together and treat them as a single service. And so Calisti is first and foremost about the lifecycle management of your mesh, but it also completely reduces, if not in most cases, removes the toil associated with standing up a multi-cluster configuration, and then just the day-to-day operational management of it. And then the final thing is, we have added a bunch of observability tool sets, which is popular this week with FSO and so forth, right?
That's a good statement.
Yeah. And so there's a lot going on there, but Istio by itself does really awesome things because it's in the traffic mix of every single API connection, gRPC connection, whatever in your microservices environment. And so we've added a bunch of observability tools on top of standard Istio, things like service level objectives, and so forth, and all of that is basically the secret sauce on top of that.
That's awesome. Cool.
Now, does the observability aggregate to like, or integrate with like App Dynamics, or is that standalone observability for the public?
Yeah. So right now, Calisti itself has all of this built into it, but as you rightly point out, that's no different than you're doing routing and switching with SNMP and syslog in your own tool set, right? It's independent of what you would use from an aggregate component. So one of the things that we're working along with Thousand Eyes, Intersight, AppD, many other people inside of Cisco, is that we're all jumping into the FSO pool together, right? And so that allows us to take data that is sourced from all of the layers of a Kubernetes and service mesh environment, from your EC2 nodes that are hosting Kubernetes pods, that all of your services, your load balancers, and so forth, and then all the Envoy proxies that are running in Istio. All of the data, metrics, events, logs, traces, all of that information that's coming from there, we want to get that into the same FSO pool that AppD, Thousand Eyes, Intersight, et cetera, are building into. And then that basically brings everything full circle, right? Is now you've got data from all the sources that you can derive end-to-end value on, and then ultimately FSO's vision is to then take action on that data, right? And so that's what we're hoping to get done.
Some pretty powerful stuff, actually.
Well, what's exciting is, you were talking about the challenges of implementing microservices architectures for developer applications. It sounded like in the attempt to make the coding process and the management of the application easier, we actually added a layer of challenge that Calisti is kind of solving, along with a whole host of other products. So that's really exciting to kind of revert back to a situation where we, like you said, just get developers back into coding, and blurring the lines potentially between operations and development, which is really all we've been trying to do for all these years in Definite anyway.
Right.
Totally.
So how are we looking on time?
We got 5 minutes.
We got 5 minutes? Mm-hmm. Do you want to talk about any other projects that are potentially coming out of ET&I?
Yeah, so we're on the observability thread, so let's stick with there.
Right.
So there's a bunch of stuff that's going on. Matter of fact, Monday morning, I had a session called C&O, or Cloud Native Observability, which is basically identifying the pain points with standard cloud native observability, which is a subset of the broader FSO, right? FSO is everything, not just cloud native, right? And so there's a bunch of stuff going on inside of ET&I around how do we better create a standard way of scraping information from any type of data source. And so I co-lead with another guy from the AppD team the open telemetry efforts at Cisco. So open telemetry, or OTel for short, is a CNCF, for Cloud Native Computing Foundation project. It's the second most popular CNCF project behind Kubernetes. There's a bunch of big players, AWS, Google, everybody's involved in it. And it's basically a standard way to create tracing via SDKs, metrics and logs into the same open telemetry pipeline. So we call it OTLP, which is a dedicated protocol. And so the momentum behind that project is, instead of having App Dynamics specific SDKs and Epsagon and Dynatrace and Zipkin and all of these different SDKs that the developer has to figure out how to instrument in their code, if we just all together as a community, get these SDKs in a healthy place where you can get logging metrics and tracing in the exact same library format, streamed on the wire the same way. We don't care where it goes. You can put it in S3 buckets or a Grafana dashboard, whatever it is. But if you can standardize that approach, you can significantly reduce the amount of toil it takes to actually get instrumentation going, regardless if it's a router, a switch, a firewall, a Kubernetes pod, or a load balancer. And so one of the projects that we're really, really invested in heavily is getting standardization of OpenTelemetry in the industry and Cisco.
That's awesome.
Oh, I actually have one of our developer advocates working on understanding OpenTelemetry as it is, because I can see a benefit directly to developers for that, because then it doesn't matter whatever tool chain they're using for this stuff. They're setting up a standard. It's, we'd say REST APIs aren't standardized, but they kind of hit the same notes.
Right.
And so that concept for developers could be really great, because now they're not worried about, oh, I got to learn this new tool, or I got to put this different piece of code in. My code just works. It's already ready to go. That's really exciting.
Yeah, well, I mean, actually, if you go talk to AppD, so AppD Cloud is 100% OTel based, right?
Yeah.
And so you go and talk to anybody that does SDKs for distributed tracing, none of them want to be in the library business.
No.
Right? They all want to, that's not money that they make, that's just code they got to write for Java, Python, Node, you name the language.
Keep updated.
You got to have an SDK for it. And that's just brutal to maintain. So if we can offload that into a standard SDK that everybody as a community, betters over time, it makes that much easier to consume.
So I have a question before we wrap up, and we talk a lot about OpenTelemetry from like up the stack, right? Mm-hmm. But Cisco actually has streaming telemetry a little bit below the stack, right? From our devices, and how are these two playing together, if at all?
Yeah, they're not playing together at all.
Oh, they're not.
Yeah, no. So the thought process of streaming telemetry and then what OpenTelemetry is doing from a community point of view, it's the same problems you're trying to solve, right? You want robust capabilities regardless of the device or source type to get their metrics, events, tracing, and so forth into an ingestion point and then back into your data pipeline in the back where you can actually massage the data and do something with it. So they're all after the same thing, but the protocols, the actual agents, the engines that run the ingest, they're all completely different. And so that's a part of what a new initiative that I brought about in the Cisco internal OpenTelemetry community we call OFI, or OpenTelemetry for Infrastructure. Mm-hmm. Because today OpenTelemetry is 100% focused on an actual application where you got an SDK, you're injecting it in Java or whatever, and then you're instrumenting your distributed traces via that methodology. So we realize that streaming telemetry and these other types of things can benefit from OpenTelemetry itself as well. So if we can actually apply the same principles from OTel
that's wonderful.
For infrastructure, router switches, et cetera, then we actually really have a really nice, solid baseline from a standard point of view.
Oh, for sure. It's a no-brainer.
Fantastic.
Yeah. All right. You want to ask a question?
Yes. Yeah, that is all the time we have. But before we let you go, I think you saw, we're going to ask all of our new guests this one question. If you could pick a superpower, what would it be and why?
Yeah, I'm pretty boring. I think I would just like to be able to fly.
Okay.
That's awesome.
It'd be awesome. I'm on a plane an awful lot.
Yeah.
So if I could fly to events by myself, that right there's a win.
All right, that sounds good to me.
Cool.
So Shannon wants to fly.
Thanks.
Yeah, thank you for being here. Snackers, thank you for yet another episode of DevNet Snack Minute. Catch us next week for another exciting tale of technology and excitement.
Thank you, Snackers. Thanks, everyone.